Welcome to the Natural History Institute. This afternoon we are interviewing Deborah Springstead Ford, artist, philosopher, professor, executive director, and the originator of this exhibition. And the exhibition is titled The Biophilia Hypothesis Comes to the Periodic Table. So Deb, could you tell us a little bit about the origin of this show?
In 2003, I was awarded an artist residency at Isle Royal, which is an island in Lake Superior. And so I was there for a month with my son Jordan and photographing, and it was all lichens everywhere. And so I wound up, for a month making photographs of lichen while I was there. But then I continued on to a place called Silica Center for Art and Ecology. And while I was there, I learned about lichens, a fungi and a cyanobacteria coming together in a symbiotic process to form lichens. And while I was there was a convening of a bunch of lichenologists, which I didn't even know existed. And it's like, well, that was kind of a wonderful thing. And the photographs that I made for that were calotypes and cyanotypes, two 19th century photo processes coming together, and I would use basically one negative with a cyanotype and one negative with a calotype printing over it and get this sort of hybrid. And so I had to chemically alter those 19th century processes. And so that's kind of my periodic table introduction. Is I have very limited, since chemistry in high school. And so my chemistry background is photographic. So that's where the science came in with finding the lichenologists, and they were able to identify these things, and that I was trying to sort of not replicate, but synthesize that symbiotic process with these two processes coming together to form something else that was completely different. And, that was wonderful. And then at that same time, I was also working on a photographic project that took me 8 years in the Powder River Basin, where a lot of coal bed methane production was happening. And it was pretty depressing, photographing these deteriorating habitats, sage hen, all sorts of things, and water laying all over the place. And so I wound up also getting at that time, during that 8 years, that was called cartography in the cultural terrain. It was, but then I wound up going to the Biosphere 2, getting another residency there, and that's where these two images were made from Chan, and was at the Biosphere, where their focus is on water. And I found, after 8 years photographing in the Powder River Basin, that it was really kind of depressing and worried about the environment. And when I found that my time at the Biosphere made it so it was much more hopeful, because everybody there is working, there are scientists there, and they wanted artists to come in and have access, because they felt there was something important about that connection between artists and scientists. And so they had that program bringing artists there, and I had an exhibit. This exhibit actually was there as well.
Sort of took you then to this exhibition on the periodic table.
That did, and so because that was called carbon, hydrogen, oxygen, nitrogen, while I was at the Biosphere, I learned about decomposition and oxidation and photosynthesis and all of these processes that use those elements. And I thought, but those elements are also part of my photographic repertoire. And I always sort of look for these intersections of symmetry, and which then I think brings us to the rest of this exhibit. Not so much the periodic table, but after that, I was very intrigued about art and science coming together. And I think photography itself is more of a science, more like science than any of the other arts. It has access that way. So bringing it to the biophilia hypothesis, I mean, I also think about the biophilia hypothesis that I just like to be outside. I just like to be in nature. And that gives, you know, and I think that's what E.O. Wilson is talking about, that then when you love it, you want to know more. And when you know more, you want to protect it. And, you know, and so you do personal research and et cetera. Then I became the executive director of a place called Playa, which was pretty significant. In 2013, I left Prescott College. Prescott College, though, really taught me a lot about that intersection. But then when I left there, it was at Playa, which intentionally brought artists and scientists together, hoping that something might rub off one to the other. They might collaborate, they might just influence, they might, who knows, you know. And they valued that, and I found that to be a really rich intersection there as well. And so I retired from there in 2017. I moved to Montana. I'm an hour and a half from Yellowstone. All of these images, except for those two, were made at Yellowstone. And I started to, because I was retired, just photograph, hang out there. And because I was predominantly a black and white photographer, all of a sudden I'm making these color photographs in Yellowstone. And then I started to try to figure out, well, what causes the colors? And, you know, most of these are in a very, very close proximity. What causes the colors there? And what I found through a little bit of, you know, their signage and then reading more books based on their signage, were that it was microorganisms, and either, you know, cyanobacteria, bacterium, archaea, phytoplankton, and there's viruses, all sorts of things, and minerals in there. That's what gave it the color, and that really intrigued me. When you see this green, it's because of a certain cyanobacteria, or this orange is rust based on how that bacterium metabolizes iron and coats itself then with this rust. For me, it's pretty exciting that I learned about these things called thermophiles, which are heat-loving or cold-loving. And then there are extremophiles, which are extreme heat or extreme cold or acid-loving. And so these colors, you know, when there's a color change, see how the green goes right next to the orange? There's usually a pH change or a temperature change in these. And so it's a different, these are microbial mats. And so when you see this, they're just millimeters, some are millimeters and some are thicker, where these organisms thrive and they carry on photosynthesis and oxidation, and some produce oxygen and some don't, and that's, you know, getting outside of my knowledge here. Some are acid loving and extreme heat loving, and so you start thinking, well, how can these things live in, you know, what is the equivalent to battery acid? But they do, and it's so what I found, you know, researching this, my own personal research, is that, you know, they have been around for, these are some of the earliest life forms out there. And we don't really see them here. You know, you would need a microscope to see them. We only see evidence of them. And for me, that's even a leap of faith, because I'm a photographer. I'm used to being able to see things. And there's something kind of curious for me about that. I can see it, but I can't see it. You know, I know it's there, but that's all. I can't really see it.
So one of the things I'm curious about are the use of these spheres. I wonder what your intentions are with those from an artistic perspective.
Well, and those spheres first appeared in that last body of work called Chan at the biosphere, partly because of that name, biosphere, and but partly because there is something optical about them. They, to me, look like a petri dish. They look like, you know, if you're looking through a microscope, how it looks, just the round, the optics of a lens. And some of them are, you know, more three-dimensional than others. Some are flat and some are three-dimensional. In this one, which is off by itself, is planet-like, even though it has a white background, you know, because I fabricated it and wanted it to have that white background. And, you know, astrobiologists are looking at all of these microorganisms because they figure if they find life on Europa or, you know, some nearby planet or Mars, that it's going to be in a similar kind of place as Yellowstone.
Right, exobiologists are very interested.
They're very interested in that. And can I have my disclaimer here that I'm not a scientist? You can put that in. I mean,
not a scientist.
I am not a scientist, you know, and so
Well,
he is. But I mean, I struggle. I struggle with this, and yet I feel it's important as an artist. It's my way of accessing science, and maybe I can help other people access science, in particular in this science naysaying environment that we're living in. You know, it is really important for me.
In our field experience, the Natural History Institute, whenever we have a gallery exhibition, we also have a field experience. And in our field experience, called Seeing the Unseen, we pried into the world of nutrient cycling and energy flow by looking at macroinvertebrates. And so maybe, can you talk a little bit about how that field experience is kind of illustrative of what you were just speaking about, how science meets art and opens the door to the public?
I can attempt to, you know. First off, I think anytime you can look through a microscope, nobody has access to that. It's like going up to Flagstaff and looking at the telescopes that they have up there, and it's like, oh, you can't see this with the unaided eye. And during that workshop we did, I talked about how photography can show us things that we can't see with the unaided eye, whether with long exposures or extremely short exposures or, you know, time exposures, all sorts of things, infrared, all the ways photography, that was sort of my focus. But when Morgan Ford, the USGS biologist, came down here, you know, he had a sampling in the water out there, and to me it's like, I love that stuff. I mean, it's like, you know, it harkens to finding tadpoles and being enamored and biophilia. That's, I keep going back to, what does E.O. Wilson mean by biophilia? I just think it's love and curiosity and wonderment at what's out there. And that's, I mean, to me, this is a gift that I can just go out and hang out at this place and be in awe-inspiring, that I don't find in a city necessarily, or something like that.
I remember you telling us whenever you did the artist talk about, I think it's this image in particular, about how silicates are a big part of the biology of the organisms. And part of this exhibition is glass. Can you talk about the connection between these glass pieces and the organisms in those silica deposits?
I will, and so there are some here. This one probably is even more so because this whole, see how they're sort of opaline? This is another area, and you can't even get near that particular area. I mean, you have to walk around it because the volcano is just right underneath, and all of the terrain is very fragile, and there are new geysers popping up because it's right at the surface. So what Bob was asking, I guess, is about the glass in the show. And so the reason this is colored, this opaline colored, is called Silica Center because it's just a precipitate, and silica is glass. And my son is a glass blower, Jordan Ford. He's also a geologist from Prescott College. And so I sent him links to actual microscopic photographs of some of the organisms, whether they were cyanobacteria or, Soulful Obus is one over there. And I said, could you, because we can't see them, we can only see the color of them because there are billions of them together. But if, we had a microscope, we could see what they look like. And so Jordan took these microscopic photographs and tried to interpret them into, for example, this one is called Oscillatory, and they're, sort of a longer filament kind of cyanobacteria. And Soulful Obus over there is kind of amoeba-like, but what Soulful Obus does, and there are photographs of it from afar, but it's acid-loving, and so it causes from the runoff, and that goes down into the earth, it gets heated up, there's hydrogen gas and sulfur, and it breaks down, basically it turns into, it breaks down the rock, the rhyolite, into
Sulfuric
muds.
acid? Oh,
Yeah,
muds.
because it becomes sulfuric acid, and that's how it breaks down the rhyolite into muds. And they're just, but it reshapes whole mountainsides there. And it's round amoeba-like, and that's what the photographs that I have of it, I think that you find in Yellowstone are Soulful Obus acidocaldarius.
Great name.
Because they're found in the caldera, and they're acid-loving, and
And they're bacteria?
yes. And this one, can I grab this little, sorry. I'll pull this off. So one of the, during my research, I found this place called the Thermobiology Institute that's in Bozeman. And so there are all these people that are researching all of this. And so here's one called thermochromatium, which is right over here. And that's what Jordan was trying to create here.
I love
and
this one.
It's sort of purple, and if you see, this is a microscopic view of it, it's sort of purple on the inside, but clear on the outside. And so this is his interpretation of that, which I think is just exquisite, and so going back even to, Jordan did just a wonderful job, I think, on all of these pieces. One of the interesting things about this is, so after the 1960s, there was a scientist named Thomas Brock, and he found something called Thermos Aquaticus. And he found it, I think it's here. And Thermos Aquaticus, it's really hot. And so it's, they were able to extract an enzyme from that called Taq polymerase, and so which is helps in this DNA chain, and it acts like a copy machine for DNA. So when like if for a crime scene and they send it off to check somebody's DNA, or if you want to find your heritage or whatever, that process all came from his discovery there.
Wow.
And which is just like, how wonderful is that it came out of that, and so it's heat loving, and so some of these things are 252 degrees of that they're still living in, and as I said in the workshop, etc., they used to autoclave machines, dental machines that they clean the tools with. we're at 250 degrees, and it's like, well, if that happened to be on those tools, that would kill that, do you know?
Be happy.
And right, and so they're finding, and that's the whole thing with extremophiles, that they find they can live in acids, you know, just because humans can't, or humans can't live at these, you know, and so they don't even know. It's E.O. Wilson, I think, even refers to them as resources that we are really untapped. We don't know what they hold for us, you know, as far as they're wanting to use formidium over here, this orange. They are trying to shrink tumors with that particular organism, and you know, there's just millions of them. There are just millions of them, and they make up the majority of species. Is it species or organisms? You know, like that they're all doing. I get caught.
Yeah, well, it might be both. I mean, it could be, if you added up all the microbial life on the planet by species, there might be more species of microbial life and biomass. Both.
Yes. Yeah. Okay. Yeah.
Could be. I mean,
You know, I think, you know, and
they're important. That's the
they're
big
important,
message, and we don't even know how important.
And you don't even know how important, you know, and there are just this is such a lab for them. I mean, you know, they have these geothermal areas in Iceland and other places, but it's wow, you know, they think that environment is where the earth is, how the earth began, and that kind of, you know, how life forms began on the earth, not how the earth began, but how the life forms began in that kind of, you know, what we almost think of as toxic, you know, environment. But
Well, Deb, the show has been fantastic, and it's a perfect fit for the mission of the Natural History Institute, which is to, you know, integrate art, science, and humanities, and kind of helping people fall in love with the earth.
that's, yeah, I feel pretty darn lucky.
Yeah, we're lucky. So, what's next?
I don't know. I don't know, except for I just spent a month in Escalante, and I kept photographing all the, you know, cryptobiotic soil there that is just kind of another version of this. But you know, I don't know. I think I don't think I'll get away from sort of the art, science, nature thing, but I don't know where this will go. You know, but
Great, thank you.
thank you. Thanks for the opportunity for this.